up for the win. And there it
USF mascot sighting Rocky the Bull. Victoria and Kaylin are analyzing if the USF mascot Rocky the Bull is sighted more often on game day versus non-game day, so we can evaluate the fun engagement with the school mascot Rocky the Bull. So now these are going to be our two probability distribution tables. On the PDT, you have your X, your numerical value, with the sightings of Rocky, and your P, your probability of seeing or not seeing Rocky. Our first PDT is of game day with the sightings being 10, 5, and 0. So for seeing Rocky 10 times on game day, there is a 70% chance of this occurring. The same values of X are used on non-game day with the probabilities only changing. Remember, the probabilities must equal to 1 in each PDT table. Alright, now these are going to be our non-game day versus game day mean, variance, and standard deviation. You've already learned how to find these values in a separate topic, which means we are not going to go over it. Now I'm going to hand this over to Caitlin, who's going to explain how to combine your two PDTs into one PDT.
Thank you, Victoria, so much. We are going to move on to the combined PDT. That is going to give us the combined sightings of Rocky the Bull on the USF campus during game days and non-game days, which we're just going to take the multiplies of the probability for the corresponding X outcome and the probability of the corresponding Y outcome and multiply them to get the new outcomes for taking the game day and non-game day sightings of Rocky the Bull. Go Bulls! Woo!
Alright, now this is going to be our completed combined probability distribution table after we used the formulas we discussed previously.
The mean of the difference of two random variables is equal to the difference of their means, shown as mx minus y is going to equal mx minus my. The variance is going to be the difference of two independent random variables, shown as o squared x minus y is going to equal o squared x plus o squared y. Okay, now moving on to the standard deviation is going to be for the difference of two independent variables. You're going to then square root the variance, shown as o x minus y is going to equal square root of o squared x plus o squared y. And now back off to Victoria. Here we go.
Alright, thank you, Caitlin. Now we're going to find the combined sightings of a game day and a non-game day. And how we're going to do this, we're going to use the mx plus my formula, which is obviously mx plus my, and that gives us 12.75. Alright, I'm tired of my country accent. I know you are too. So, the variance sightings of game day and non-game day, we use the formula mx minus y, which is mx minus my, and then that's going to give us negative 3.75. Alright, now to find the combined variance on game day and non-game day, we're going to use the formula o to the power of 2x plus y, which equals o to the power of 2x plus o to the power of 2y, and that's going to give us 15.2513. Alright, lastly, we're going to find the difference variance of game day and non-game day. How we're going to do this is we're going to use the formula ox plus y, which equals the square root of o to the power of 2x plus y, and that's just going to be our sum from the last problem, which is going to sum to 3.9053.
Hey class, I'm your guest star Ava Blanco, aka Victoria's best friend and Kobe's cousin, your Wall of Famer. I was just asking if you could give Victoria, Kaylin, and Kobe all A's on this project.